We're going to look at finding exact values for different trig ratios. And so first we need to just talk about what the trig ratios are. Sine, cosine, and tangent are trig ratios that you've learned about before. They're called ratios because it's one side length compared to another. So sine is opposite over hypotenuse. That's a ratio, opposite to hypotenuse. And the way it works is the sine of a given angle, no matter how big the triangle, the right triangle that it's in is, will always have the same ratio of opposite to hypotenuse side lengths. And then cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and that's not anything new to you. These are the three primary trig ratios. There are also three secondary trig ratios, which are CSC, which is cosecant, and then there's SEC, which is secant, and COT, which is cotangent. And this is actually going to be on your formula sheet, that cosecant theta is 1 over sine theta. Cosecant is the reciprocal of sine. So if we were looking for a ratio of side lengths, if it's the reciprocal of sine, what would the ratio of side lengths be for cosecant? Yeah, it would be hypotenuse over opposite. So sometimes when you're dealing with cosecant, you want to think about hypotenuse over opposite, or sometimes you'll find the sine and then flip it over, take the reciprocal. It's up to you which of those you want. What would secant be as a ratio of side lengths? Hypotenuse over adjacent, right. And then cotangent, adjacent over opposite. So you don't really need to remember these three ratios, but it is going to be worth your while to remember cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Even though I do believe it's on your formula sheet, it's something that you're going to use a lot and not want to have to be looking up all the time. So those are worth remembering. We don't use these very much anymore, these cosecant, secant, and cotangent. They used to be used a lot more, like before your time or before my time, when people didn't have handheld calculators. Because all of our trig ratios, we used to get in a big table of ratios. Like I said, this is before I was in school, because when I was in school we had calculators, right? Scientific calculators. But before they had scientific calculators, all the trig ratios would be in this big table of ratios, and cosecant, secant, and cotangent were useful then because they were, sometimes it was easier to work with the reciprocal than the than the original one. Anyway, that's just kind of on a side note why we have them and why you haven't learned about them before, because we don't really need them anymore. When you're doing basic right angle trigonometry, having calculators means we don't need them anymore. These questions ask you, what is the exact value for each trigonometric ratio? And it says sine of 3 pi over 4. 3 pi over 4 is an angle, right? So what's the sine of that angle is what it's asking. You could sometimes just punch these into your calculator, but that's not going to give you always an exact value, and that's what we need to do, is figure out how to get an exact value. But the calculator will be useful when we go to check our answer. And once in a while you luck out and it actually gives you an exact value. So if I just punch sine of 3 pi over 4 into my calculator when my calculator's in radian mode, because this angle is measured in radians, I get 0.7071067812, which is not an exact value, right? That's rounded. So what we need to do is consider the stuff that we talked about yesterday, the special triangles and that cast rule. So first thing I want to do actually with this is draw a little picture of where 3 pi over 4 is. Which quadrant would it be in? 2, yeah. So 3 pi over 4 is like there, right? So if that's where 3 pi over 4 is, it's this angle from the positive x-axis to there, because the angle's in standard position. But what is the reference angle? Pi over 4. So the reference angle is just this angle in here. It's from the terminal arm to the closest x-axis. So in this case, it's that negative x-axis. So it's the leftover. And again, if you think about taking that circle and splitting it into 4 pieces, 1, 2, 3 is where the terminal arm is. There's only one more piece to get to the x-axis. So it's 1 pi over 4. What we're going to do is find the sine of the reference angle. And the sine of pi over 4, we can look at our special triangle. Special triangle like this, 1, 1, root 2, pi over 4. Sine is opposite over hypotenuse, so what's the sine of the reference angle? One over root 2, right. Opposite over hypotenuse. If you know that special triangle, then it's easy to find. But that's not the sine of 3 pi over 4, that's the sine of the reference angle, so sine of pi over 4. So then we need to look at what is the sine of 3 pi over 4. And it's either going to be 1 over root 2 or negative 1 over root 2. Which one is it? If we think about that cast rule, it's here. S means sine is positive, so this is positive. 1 over root 2. So the sine of 3 pi over 4 is actually the same as the sine of pi over 4. But it won't always be the same as the reference angle. It could be the negative of that. The second question here asks you to find the secant of negative 2 pi over 3. So we need to think, where is negative 2 pi over 3? Which quadrant is it in? No, not the second. It's negative, yeah. I didn't think you were. So yeah, because it's negative, we're going in the clockwise direction. 1, 2, it's right there. So it's in the third quadrant. And what's the reference angle? Pi over 3. It doesn't matter positive or negative. The reference angle is always going to be positive. It's just the distance between where the terminal arm is and where the x-axis is in terms of how many degrees or radians that is, depending on which we're working in. So that angle in there, and it's pi over 3. This one is secant. So there's kind of 2 different ways you could approach it. Secant is the reciprocal of cosine. So what I would do with this one is find the cosine of the reference angle and then take the reciprocal. But you could also just find the secant using, see this, I have to think about it. So cosine is adjacent, hypotenuse over adjacent, if you want to do it that way. Doesn't really matter which way you want to do. But I'm going to do the cosine of pi over 3 first. So we need this triangle, the 1, 2, root 3 triangle. And pi over 3 is down here. So the cosine is adjacent over hypotenuse, 1 over 2. Which means the secant of pi over 3 is 2 over 1, or 2. Then we just need to look at the secant of negative 2 pi over 3. And is it positive 2 or negative 2? In that third quadrant, only tangent is positive, which actually means tangent and cotangent because they're reciprocals of each other. But sine and cosine are negative, which means secant is also negative, so this should be negative 2. The other type question that I want to look at with you today is this one. It says the point A at -4, 3 lies on the terminal arm of an angle in standard position. And then what is the exact value of each trig ratio for the angle? So I'm going to just plot that point first. -4, 3. So it's like around there. Right? Over 4 to the left, up 3. And it says it's on the terminal arm of an angle in standard position. So if I want to draw the terminal arm, it's going to go from that point to the origin, right? Because an angle in standard position always has its vertex at the origin. So I'll just draw that line. So here's the angle that we're talking about, that angle there. And it's asking us what is the exact value of each trig ratio for the angle. This is not a special triangle question, right? Because those numbers -4 and 3 don't show up on a special triangle. But we're still going to draw in a triangle and use a triangle to figure it out. We always are going to draw the triangle, just like we do with the other ones, to the closest x-axis so that we're talking about the reference angle. The reference angle always measures to the x-axis. So that's where I need to draw in my triangle. And now I'm looking at this little triangle here, like this, that has a base of 4 and a height of 3 and a right angle there.
Why is it not negative?
Because I'm just talking about the size of the triangle, so I don't need a vector in there, right? Just a scalar 4 instead of -3. 4 instead of -4, because I'm just talking about the size of it. And we're going to look at this angle here as the reference angle. And we want to find the exact value of each trig ratio for that angle. So we want to find the sine of that angle and the cosine and the tangent.
Do you want reciprocals too?
Yeah, let's do those two because that's easy enough, right? So we'll do cosecant, secant, and cotangent. One of those is already really easy to find, right? Do you know which one? Tangent, because tangent is just opposite over basis, 3/4. And then the cotangent would be 4/3. We do need to consider what's positive and what's negative. So since we're in this quadrant, yeah, this will actually be -3/4 and -4/3. Because sine is positive there, right? Which means the other ones are negative. But how am I going to find the sine? Sine is opposite over hypotenuse, and I don't know the hypotenuse. To find the hypotenuse, which we'll call C, C squared equals 3 squared plus 4 squared. So 9 plus 16, which is 25, and then the square root of that. So C is equal to 5. So then I can find the sine because it's opposite over hypotenuse. It's 3/5. And it's positive because we already determined sine was going to be positive. So what's the cosecant of that angle? 5/3, just the reciprocal of sine. And cosine? 4/5. -4/5. And then the secant? -5/4.